Welcome, everybody. What do you think about? What do you think about open hardware? Do you think about electronics, 3D printers, experimenting, trial and error, trying stuff out and iterating? Maybe community-built useful things like flood detectors and air quality monitors? I work for an organization that uses open hardware in the most challenging contexts on the planet. Field Ready is a humanitarian NGO, and we make essential items for people in crisis situations, such as after a natural disaster or in a refugee camp. And we combine appropriate kind of low-tech ideas with high-tech digital manufacturing like 3D printing and CNC. And so the kind of challenges we face are different. We're making do with less than ideal raw materials, maybe less than ideal equipment. We're making items that are needed urgently, and we still need to make them good quality and safe. And we're pioneering. This stuff often hasn't been done before. We're making things near where they're needed that have never been made there before either. I have colleagues right now in the Caribbean responding to a hurricane. When they make an item from an open hardware design to save life or preserve life, they need it to work first time. They need to know they're going to get a good print from their 3D printer. They need to know that the instructions for assembling an item they may never have made before are going to work out right first time. When you're 3D printing in a truck, in a monsoon, in a displaced persons camp, like my colleague Abby here, you don't want to do trial and error. You need it to work. And the power of open hardware is that Abby isn't limited to stuff she's designed herself. She can access the wealth of great designs on the internet, but they have to work. When you're making a really safety-critical item, you don't just make it, you test it. And here's a rescue crew using a commercial lifting airbag to lift a truck to rescue people. And we've designed and made search and rescue airbags just like that, made locally from available materials and tools in Syria. And we've tested those. We actually test to the equivalent of the British standard for lifting airbags. Our airbags lift 5 tons. And we've made over 100 now in Syria, and they're in use and they're saving lives. But even something like a pipe fitting, like this one, pipe fittings can be useful too. We've made these in Nepal, and it's a simple item, but you still have to actually sort of think about, will it hold the pressure of the water? Is this plastic okay? If there's drinking water sitting in the pipe for a while, is it going to leach any toxic chemicals? So we do a risk assessment. Who here has done a risk assessment for something? Anyone? Oh, a couple of you. That's good. Risk assessments are great, right? They're not some huge admin burden. A risk assessment is just thinking through, what's the situation where we're going to use this item? What are the risks in making it? Or what might go wrong when it's being used? And can we make it safer or more reliable? And so this is Field Ready's vision, that in every humanitarian crisis, people have what they need, when they need it, where they need it. And we do that through local manufacturing. But you need more than just a design and from open hardware. You need information about the risks and about how you're going to test stuff. Because at scale, if we're going to help the millions of people affected by disasters and conflict, it's going to be folks who aren't design or manufacturing engineers who are making stuff. And that's part of our shared vision, right, for open hardware, is that more people can make things. And it gets easier. Things like 3D printers make it easier for people who are not trained engineers to make items. So here's Johnson. We trained Johnson in Haiti after the earthquake to use 3D printers, and he is now training others to train even more people to use the printers that are available there. So there's lots of different people involved in making. And it also means folks making in less than ideal places. Maybe it's a dusty environment, or it's humid, or it's high altitude, or power and connectivity are kind of intermittent, like here in rural South Sudan. And maybe it means making do with less than ideal materials as well. When is it okay to use recycled filament in a printer? When is it okay to recycle other materials? Maybe because you have excess of them, this is a lot of plastic bottles, or maybe that's all you've got. And when is it okay to use those as raw materials for goods, which might be printed or injection molded or formed in other ways? Do you still get a good enough quality item? So for our vision of all kinds of people, in all kinds of tough situations, making the things they desperately need, you need the designs to work well, you need the instructions to be clear and solid to people across many different cultures, and you maybe need to know when you're going to pick one design rather than another. So You might be thinking we're making our lives really complicated here because you've all seen what happens on the news after a disaster. Aeroplanes arrive with loads of supplies, so why are we making locally? Well, there's a few reasons, but the most important is that we work where supply chains don't. These are our Syrian engineers in their workshop, and they've got some supplies. They're able to access certain raw materials and tools, but you can't FedEx stuff there. There is no Amazon Prime in Syria. Supply chains break. Maybe your border gets blockaded, or the bridge that connects your village to the rest of the world is washed away in a flood. Or maybe there are armed bands roaming in your region and you're cut off from the rest of the world for weeks or even months at a time, so goods aren't reaching you. If you can make stuff locally, you're resilient. And it's often easier or cheaper to access raw materials than it is finished goods as well. You still need the means of production, you need some tools or some machines, but you get to choose what you're going to make, and it can be much more effective. Particularly, this is good for repair parts. So in Field Ready, we're often asked to repair high-value assets such as power systems or hospital equipment. This is a baby warmer in Nepal. We found 5 of them, all out of use because the corners had broken. And we were able to make some new corners. This is second-hand donated equipment. No one anywhere in the world can get spare parts for this. The only option you have is to make stuff. And so if you've got the means of production, you can do that. And of course, the other thing is you can fix, if you're using open source manufacturing equipment, like 3D printers, you can fix those too. So you're really empowered to take control. Traditional aid supply chains are slow and complex and expensive. Between 60 and 80% of the aid budget goes on logistics. And despite that amazing spend, people go for months or years without access to the supplies that they need. So we simplify it. Shipping goods into an area also isn't great for the local economy. Does anyone here remember the Ethiopian famine in the 80s? Anyone old enough like me? 1 or 2? So you may have seen on the news back then, there were these trucks full of American grain rolling through Ethiopia, rolling past fields growing grain. Not enough, but some. And the free American grain destroyed the market, so farmers couldn't sell their goods anymore. This does not help a community recover after a situation like that. And it's exactly the same shipping and aid supplies. If you ship in stuff they could have made locally, then you're starting to lose the local economy. It makes it much harder to recover later on. So to realize this vision of everyone being able to make the stuff they need, there's a lot of stuff you've got to do. And Field Ready works on all of these different things. But today I'm focusing on the actual designs and the things, and some of the information around that, rather than the how you get machines to people. So how can we get reliable designs, complete instructions, an understanding of the risks of making and using a design? We're a very small NGO today, and so we thought that maybe we could crowdsource some of this. And so we catalyzed the creation of Humanitarian Makers, a global network of designers, engineers, and humanitarians. And our original dream was that they'd be able to help us with design, because CAD is pretty hard, right? And it's time-consuming, and so maybe remote help from engineers and designers elsewhere who aren't in the field doing disaster response could help. And it has helped a bit. We've had some great results from hackathons and from community designers. But the fact is that human-centric design needs really great information or some back and forth between the people doing the design and the people seeing the needs. And it was really difficult for us to get that to work with folks in the field and remote design help. So even when we're working in comparatively stable situations like recovery and reconstruction, so not sort of in the first week after a disaster. So now we're starting to think maybe the community are more used as testers. People trying out designs, reporting whether they are making them successfully, if they use maybe in a different place, a different printer, some slightly different tools or different raw materials. Even just knowing what raw materials are what is kind of interesting. We've tried making the airbags that we make in Syria and other places, and sometimes different countries have different ways of referring to sheet materials and stuff. You can't always get a drop-in replacement. So seeing if the community can follow someone else's instructions and get a good design. And maybe improving the documentation towards our sort of dream of fully featured, step-by-step, photographic instructions. And also checking whether the end result is an item that actually does what it says. So in the next few months, we're going to be trying this out with Humanitarian Makers and seeing if it works. feels like it might be an easier way in for some makers who are perhaps more comfortable testing someone else's design than they are starting design from scratch. And we do some testing ourselves. Here's our Fetoscope, one Fetoscope. We've tested it in practice with clinicians who otherwise didn't have access to a Fetoscope, and it's useful, it's effective, but it's not formally tested or certified or anything like that. And here's our engineer Ram. He's in a health post in Nepal, handing over some supplies to the clinician, and you can see the Fetoscopes there in bags. So think about a medical item that maybe needs to be sterile, like an umbilical cord clamp, which you use to clamp off the cord after a baby is born to prevent infection. And those infections kill many babies around the world. This is actually Field Ready's origin story. We went to Haiti 2 years after the quake. Disasters, when they stop being in the news, often donated supplies kind of drop off. And when we got there, there really weren't many supplies around. So in an ideal world, your umbilical cord clamp is sterile and it's wrapped and it looks just like this. In Haiti, when we arrived, they were using shoelaces to clamp off cords. So we were able to 3D print them a clamp like this one. We co-designed it there. It's better than string, but it's not as good as that. Is it good enough? Medics are often, they're not biomedical engineers, and they actually don't know what a different manufacturing process could mean for whether the end item is as good as what they might expect, what the different risks might be. And you also see this ideal clamp has a bunch of certifications and things down at the bottom, which you can do if you're making things in a factory. You can do all that great testing, but it's really different if you're making locally. How can we understand what's needed in terms of quality? And how do we demonstrate that if conventional standards processes don't seem to work? And there's all the things to think about for the folks making the items, right? So when we 3D print a clamp, we always use new filament rather than recycled. We wear sterile gloves. As soon as it comes off the print bed, we put it in a sterile plastic bag. All that stuff may not be obvious to someone who's just downloaded a print file. And so you need to think about how do you explain the risks around manufacturing, around testing the item, and for using and maintaining it, because there won't always be a skilled engineer who can help out. Here's a trivial example on Thingiverse, a scalpel handle. It tells you about how you need to check the materials and not to cut yourself. So to start, we're getting some open risk assessments. But we're imagining a world where open hardware platforms have a lot more information in them than they do today. More about testing, about risk, and supporting collaboration around test processes, sharing test results, and explaining when you might use an item. So Thingiverse is our go-to platform today, and this otoscope design actually needed way more structured documentation than Thingiverse offered. So we have the documentation on Apropedia. And this otoscope is a really nice design. We actually downloaded it from Apropedia, we remixed it with some help from some clinicians to make it better, and it's now been found, it's being used by another team in Gaza, and we're getting improvements back from them, so it's a good open hardware example. But here on Apropedia, you see there's loads of information, and you've got this sort of rating is prototyped on the open source appropriate technology scale. But there's still more that we could add in here. Version control of the design files would be nice, because sometimes you need to know a specific version is the one that you want to use that works really well. So this is the Oxfam bucket. It's renowned in the humanitarian sector, and you can see a lot of thought has gone into making it a really reliable bucket for aid. We can imagine Oxfam certifying a specific design and manufacturing process for this bucket, and maybe marking it up on a platform. They actually do certify the bucket now, but that's to be made in a factory somewhere else. So we're also thinking about a platform where an authorized body, like Oxfam, can mark a specific version of a design as safe and reliable. But what do traditional factory-tested or audited standards look like if you're doing hyperlocal manufacturing? And people in need, just because they're in need, doesn't mean they don't deserve good quality and safe items. So if we have our certified design for a bucket, do we trust just anyone to make it? Or do you want just authorized makers who are qualified and capable? You don't want someone getting a bucket that looks right but has actually been made badly, particularly if it's safety critical. And if someone gets an item that then breaks, who's liable? The maker, the tester, the designer, the person who funded the program? And this really matters if you're imagining aid supplies that might be being purchased by a big NGO or an aid agency, the sort of organization that has funds to reach all those refugee camps and disaster responses, but also wants to have a clear picture of the legal world. So we don't have answers to all these questions yet. Our use case of distributed hyperlocal manufacturing of open hardware for life-saving and life-preserving contexts is quite new. And you can't see the right-hand side of my slide, but we're still thinking about what that means and would love to get help from others to make sure that we get processes that mean that we can deliver the items that folks need. Because there's huge potential here to enable the millions of people around the world who need access to items to get them when and where they need them. And we're bringing together engineers and humanitarians to have real impact, finding ways to talk about these risks and standards, maybe even sharing risk assessments. I love the idea of open risk assessments, because with more eyes, all bugs are shallow, and risk assessments are about thinking outside the box. So we'd love to have our folks in the field who are working in disaster response having help from the open hardware community to help them make the things that people need. So maybe next time you're looking for a project, instead of starting a new design, you might be able to help out test one of ours and making a bite-sized contribution to a global challenge of getting people the aid they need. Let's make testing stuff cool. We celebrate invention. We should celebrate the folks who do testing and documentation too, because without them, we can't help people. So we want to deliver the power of local manufacturing of open hardware to the millions of people around the world who need it the most, and to give them the supplies they need when and where they need them, even if they maybe don't have ideal materials or tools or skills. We can all help with this. Please join us. Thank you.